All right, got some more trends. These are going to be overarching trends across the entire table. So we may talk about how things change across periods and in groups, but really there's kind of like a whole table side. So the first thing we want to talk about is our atomic radius. Right? This is very similar to the radius of a circle or a sphere that you're used to, right? But it's how far the nucleus is from the outer shell of electrons. What do we call those electrons that are in that outer shell? Valence electrons. Great memory if you remembered that. Oops, I am spelling this wrong. All right, so the closer the electrons are to the nucleus, the stronger the hold of the atom has on them. So atoms that have small radii have a nice, good, strong hold on their electrons, whereas things with large radii maybe don't hold on to their electrons so well and form positive ions. So here is the trend on the periodic table. So what do you see happening, say, as you go across a period? What about as you, say, go down a group? What's going on with the radius? All right, so radius increases down a group, but decreases across a period. All right, or you can think of it, radius increases in this direction, down and left. So a couple of other different but very similarly related trends are ionization energy and electronegativity. And these both kind of relate to what kind of ion an element tends to form. All right, so ionization energy is the energy required to remove an electron from an atom. You can also think of it as the likelihood to form a positive ion. All right, so it's the likelihood to lose an electron or be positive ion. All right, so you can see the darker purple have high ionization energies. All right, so the darker the purple, the more energy it takes to remove an electron. All right, which means those ions, those atoms aren't going to form positive ions. All right, whereas the light or the white colored elements down in the bottom area of our periodic table over here, those guys don't have very strong ionization energy, so it's really easy to pop off an electron. So they're going to be more likely to form positive ions. All right, so you can see that ionization energy increases across or to the right and up. All right, so ionization energy increases in that direction, opposite your radius. Electronegativity, all right, is the ability of one atom to take an electron from another. All right, so this is the likelihood of gaining electrons. Or becoming negative. All right. You can see based on the values here, again, this increases going across or to the right and up the periodic table. All right. As we talk about noble gases, we'll talk about why Noble gases don't have an electronegativity value. They also have really, really, really high ionization energies. We will talk about why that is when we define noble gases. All right. So this picture shows the overall trend. Going across or to the right on the periodic table, your atomic radius decreases. All right, so that means the nucleus is going to have a stronger hold on those electrons. So your ionization energy and electronegativity both increase. All right, because these elements, especially towards the top corner over here, are going to be more likely to form negative ions or be a noble gas. All right, and then as you go down a group, right, your atomic radius is going to increase, which means the valence electrons are going to get farther and farther away from the nucleus. So your ionization energy decreases and your electronegativity decreases. And these guys are more likely to form positive ions. So give a couple of these a shot. All right, so in the diagram above, which arrow correctly indicates increasing ionization energy within a group? All right, so first thing, figure out if group is a column or row, and then think about which direction ionization energy goes. All right, so groups are columns. Oopsies. And ionization energy is strongest, say, over at this corner. All right, so that means it's going to be arrow B, going up. Let's see, let's do an atomic size one, this one. In the diagram above, which arrow correctly indicates increasing atomic size within a period? All right, so there's row, and if you remember, our atomic size, our atomic radius was biggest over here, so that means arrow C is correct. All right, so last thing you want to know in relation to these different trends is what goes on when you actually do form ions. All right, so the radius will change, and this is going to be when you are comparing, an atom to its own ion. All right, so for example, when an atom loses an electron, all right, it gives away some of its negative charge. Think about what type of ion you're looking at, and then look at your pictures. All right, so the ion is going to be positive when it loses an electron. So the charge is going to be positive. What do you see happening in the picture here with the positive ions? The radius does what? All right, looking at these positive ions, it gets smaller. All right, and then when an atom gains an electron, the ion charge is and the radius gets, so when we have negative ions, right, the radius is going to get bigger. All right, and that should make kind of intuitive sense, because just think about it. You pull an electron out, there's less stuff there, so the size of the atom can get smaller. If you put another electron in there, there's going to be more stuff there, so the size of the electron is going to get bigger.